All right. Okay, so if we jump over to Canvas and look at what we're going to do today, we're going to continue our adventure in the rigging pipeline. Now, hopefully you guys have started to get some comfort with creating the skeleton. How went the paint weights?
Good.
Good? Yeah, it's a process, right? One of the things that I would suggest as we go through this process is think of bands of control with the paint weights. You just want an area right around the locator or right around the joint. Those are the polygons that you want to have assigned to the weight maps for that locator. That's a good place to begin. Oh, the power outage.
About like editing the location and the orientation of the joints after you place the entire skeleton.
Okay.
Once I had all of it in and bound, and even before it was bound, some of the skeletal joints in like the spinal area were kind of rotated a little bit.
Okay.
But when I tried to go in, and since they're all parented, it would rotate the upper half of the entire skeleton.
Like oddly.
Oddly,
Yeah.
so I wasn't able
Okay.
to get it to like have the rig just like bend
Yeah.
on its back at all.
Okay.
Well, like it bends, but it kind of like bends sideways a little bit. And I tried to unparent the specific joint and alter it, but it still was affecting the other ones.
Okay. We definitely can take a look at that today. That's one of the things that we're going to talk about today is the idea of resetting, the idea of freezing our transformations. And we have to make sure that the rotation and the location of all of our joints is kind of dialed and perfect before we start freezing the transformations of our rotation, of our transformations, excuse me. So we'll look at that a little bit here in a minute, for sure. We'll get that question answered. All right. Okay, so week 7. So this week we're going to talk about inverse kinematics, okay? This is probably going to be the most technical week we've had so far, okay? There's going to be a lot of science that we're going to throw at the rig to increase the functionality of the rig itself. So this is something that you're going to have to practice a couple, 3 or 4 times, and we're going to do it together in class, okay? And then you're going to go home and do it 2 more times. You're probably going to need to do it 1 more time after that to really kind of galvanize your understanding of the sequence. I think I've mentioned a couple times that there are moments inside the rigging process where we have to be dialed with our sequence. And if we get off, even by 1 step, the remainder of the sequence is just not going to work. Well, today is one of those days. Today is absolutely one of those days. And to help you out, I've actually written down the sequence for you. It's under this leg, IK, and reverse footlock instructions, okay? So this is going to be a good resource for you going forward. It's literally a step-by-step instruction on what you need to do. So if you pair these instructions with a live stream, you're going to have a really good kind of resource going forward to help you understand this process. As a reminder, there will be a rigging exam, okay? Not next week, most likely the week after, okay? Where I'm just going to come in with a model that you've never seen before. Okay. And you're going to run through the entire rigging process in a morning, okay? So please keep that in mind. If you're kind of shaky on this, start practicing, okay? You have to get some iterations in this, some repetition to kind of go through the process. It will absolutely be open notes, open resources. You could even like watch the live streams while you're doing it. I don't care, because that's actually part of our process. It's not about knowing everything. It's about knowing where to go to find your answers, right? So keep that in mind. I'm going to ask you to do this by yourself, and I'm going to be hardcore about it. Like I will be sitting in my office listening to your screams out here. Right? No, I don't. I'll be sitting over there. But it's very much going to be on your own going through this process, okay? Everything that we've done in so far, you're going to be expected to do in this kind of exam here in a couple weeks, okay? So keep that in mind. And if you can make the rig, guess what? Congratulations, you've done it, right? That's kind of the goal, right? A functional rig. All right. So this week, we have 2 things. I mentioned just a second ago that you're going to have an opportunity to get some practice creating some inverse kinematics, okay? And this reverse footlock. This is about as industry standard as we can make it when it comes to this type of functionality in the rig itself. As I think we've mentioned this a couple times before, really what we want to create here is a small little machine for our character, right? and we want to give access to just certain parts of this machine to the animator itself. We're trying to create a whole series of control surfaces that expose complex machinery to folks that have no interest in complex machinery, right? Because animators, they're just focused on performance. They're focused on creating the illusion of life. They really probably don't care about reverse footlocks and inverse kinematics and spline rotations and all that jazz, right? They probably just fundamentally don't care. That's not their job, right? But we need to make it accessible to them. So in addition to exploring the reverse footlock, we're also going to talk a little bit about how to add control surfaces to our rig so that it's very easily manageable, right? We're creating a small, simple little marionette, like a little puppet, right? Now we need to create the strings of the puppet so we can start moving our puppet around a little bit easier, okay? So that's going to be the goal and the focus today. Some inverse kinematics, reverse footlock, and then, of course, the control locators for our rig. All right. Easiest lab assignment ever. We're actually going to do this together in class today, okay? Okay, so basic leg, inverse kinematic. This is going to be our playground in a couple minutes, okay? So download the project file. And let's take a look at what we got going on. So under the basic leg, we're doing the lab. If you go to the lab, this is the, there we go. Let's open it up. Get things rocking and a-rolling. While this opens up, I'm going to draw an example of something that will hopefully help you illustrate the power and the importance of inverse kinematics. Here we go. All right. So let's check it out real fast. Let's do, just as an example, here's my leg. This is what we're going to be working with today. Ta-da! Pretty cool. Okay. Very, very simple architecture. This is kind of a cartoony leg. So the proportions are a little bit wonky, if you will. Okay. This is actually the hip and groin section up here. So it's a pretty, it's a gigantic boot. Okay. It's a regular sized leg with a gigantic cartoony boot. Now, in order to get this to work correctly, our traditional skeletal system kind of presents some challenges, and I'm just going to very quickly just put in 3 joints, okay? Oops, I had symmetry on. Let me do that. I don't want 6 joints. Let's turn off symmetry. Let's try this again. Dominic earlier had a question about orienting all the joints, okay, and making sure they're aligned to a common plane. There's a couple ways we can resolve that problem. Here is a simple, easy way, and this is probably the method that I use most directly. Apply your joints in an orthographic view. All the rotation orientations for our joints will be pretty much locked to the work plane to this view, okay? So I always pop it into like the front or maybe like the side view if I need to work in there when I need to add my joints. That way everything is kind of oriented correctly, or at the very least a common angle. All right, so here's the problem that we have when it comes to working with skeletal joints, okay, or just joints as a whole. Really what they are gigantic hierarchies, and you can see that in action over here. Here's my hierarchy. Here's my 3 joints. Here's the root, top, which was kind of we'll pretend that's like the hip joint, okay? This is the knee, and then that's the ankle joint way down there at the bottom, okay? Now, if I wanted to very quickly go in and just raise the ankle, how would I have to do that in this structure? Kinda. I mean, it works, right? But if we're thinking in the terms of human anatomy here, really all of these joints are rotation joints, right? We don't actually move our joints. We don't translate them in 3-dimensional space. We rotate them, and the visual appearance is that of something that it's moving, right? So if you like raise your ankle, you're not actually raising your ankle. You're rotating your hip joint. You're actually rotating your knee, and then your ankle's coming along for the ride, right? This is called forward kinematics, when we're strictly going in and we're rotating things. So I can rotate my hip, can come down and rotate my knee, Okay, maybe rotate my hip even a little bit more. And now I've created the appearance of my ankle being raised, but it's not, it's pretty laborious, right? This is forward kinematics, where we rely almost exclusively on the native rotation channels of each item itself, right? Now, forward kinematics is not a bad thing. It's actually something that we want, because at times we want to be able to control rotation of our objects very, very directly. Our arms are a great example of that. The animation for arms should almost always be forward kinematics, right? Because we want to be able to move in gigantic arcs and big circles with our arms, right? Most of our arm motions, except for maybe like if you're doing a pull-up, okay, this piston kind of type motion, most of our arm motions are going to be big circles, okay, for the most part. You think about someone walking, running, jumping over, we're kind of doing this motion with their arms for the most of the part, right? So forward kinematics plays a big role in that because it almost always gives us a defined movement arc, right? We like forward kinematics. However, for movements that are more kind of piston-y, okay, like our legs, unless you're like a world-class athlete or like some like gymnast, you're not like, or maybe some like, kung fu master, you're not really rotating. I can't even do it. I'm going to hurt myself. Like you're not going to be rotating your legs in big circles, right? For the most part with your legs, you're just going up and down like a piston, okay? So inverse kinematics allows us to create that movement quality very, very quickly without a lot of fuss and fuss, okay? So in my mind, forward kinematics, circles, inverse kinematics, kind of like piston movements up and down, okay? The legs are pistons for the most part. We just compress the spring, we expand the springs. We're not doing these big circular movements with our legs like we often find with our arms. Okay, so let's put this back, put my leg in here real fast, and I want to show you just how it's different. So I'm going to duplicate this entire hierarchy, and let's just be, so this would be underscore FK, that way we can just keep an eye on it. Right click, duplicate, duplicate hierarchy. Now we have another one, and this is going to be IK. Okay, so FK, forward kinematics, IK, inverse kinematics. And I'm just going to grab the root, good old IK. That way we have a comparison. Yeah, go ahead.
Can you go back over to FK? I didn't get that.
Yeah, so FK, we're relying strictly on the local rotation channels of that item, right? So we're just rotating things, okay? So the hip here, fire off my item transform tool, I can rotate it up, which allows me to take my knee, rotate it down, and now I've created the appearance that I've moved my ankle up. But we're still just exclusively relying on the rotation of the joints to get the pose that we're after, right?
Well, where do you find that FK?
So great question. Where do I find FK? All skeletal joints are natively, by default, FK.
Okay.
Yeah, everything, even just basic item level transformation, that's forward kinematics, if you will, okay? We're just relying on the local rotation properties of that item to determine the movement of its hierarchical components, okay? So everything is FK initially. Great question. Yep, and I just duplicated the hierarchy. Now earlier someone said, hey, we just move the joints, and we really don't want to move our joints because check it out, now we're actually changing the distance between the locators, which is going to give us a tremendous, it's going to break our rig, basically. All of our weight maps are just going to go, and it's just things, it's really kind of fun to see your rig break. Did anyone have their rig break over the last week? It's really kind of awesome because then it like turns into like, it just kind of like spasms out and the geometry just kind of like goes everywhere, right?
They were already bound to the skin. I just tried to rotate one of them in setup. I turned on setup mode. I unparented it and I tried to rotate it and then I turned off setup mode and my dude was like split in half and like flying back.
Yep, that's it. That's a broken rig, right? The good thing about rigging is that it's immediate gratification. You know instantly if something's not working, which is nice, right? That's a good help. It's not like when you're rendering something, you got to commit 2 hours to render to go, I didn't add enough reflection rays, and I got to re-render this thing all over again, right? Okay. So we don't want to ever move our joints. We only want to rotate them with forward kinematics. So let me just put this, my example, back to something that we had earlier. Now, forward kinematics takes some energy, right? I now have to move a whole series of items inside of our OpenGL viewport to get us where we're going. So it takes some energy. It's not impossible, but it just takes some energy to start moving the rig around using forward kinematics. Inverse kinematics allows us to create some math and some relationships between two different items inside of a hierarchy, and we're going to let the computer figure out how to rotate that middle part for us, okay? So it kind of simplifies things down a little bit, and it's really a system that's designed for like legs. It's best for legs, or when we need to do like piston type movements with our arms, right? Okay, like this, that'd be inverse kinematics. Doing this type of motion with your arms would be wicked hard using just rotating things. Having to rotate your shoulder, rotate your arm, that would be kind of tough. So this is a good example where inverse kinematics would be helpful, okay? I've seen some really high-tech rigs that you can blend between inverse and forward kinematics with a little slider. But right now, let's just talk about how we can add inverse kinematics to our simple leg structure over here. Now, like everything, we've got to be in setup mode, okay? Let's run over into setup mode. And FYI, I'm using, you know, I should take a step back here for a second. And really what I need to do is that I need to start drilling home the importance of the Moto Beta layout, okay? This is the future of Moto, okay? It really is, okay? I would start to get very comfortable with how Moto is laying out the interface in the beta layout. This is a direction that they're going, and it's very, very, very different. Did any of you guys download the public beta that's going on right now for Moto? 12.2.1. Or is it 2? I can't remember. I can tell you. Yeah, 12.2 version 1 is in public beta. Go check it out. You're going to start to see some major tweaks to the Moto UI. So get used to working in this Moto beta layout. It kind of turns our layout system on its head for a little bit. It's kind of a challenge, but get used to it because this is the direction they're going in, right? Because over in this environment, all of our tools, all of our layouts, or all the tools for our layouts are docked up here. You saw this in the other layout, but they're really driving it home here. So here's all of our setup tools, okay? And of course, setup mode is still the little guy. Now we're in setup mode. Oops. And we get the lovely dark, dark, dark gray interface, which is I actually kind of like, personally. I think it's pretty rad, okay? But in order to apply inverse kinematics, we have to start making some selections first. Now, on the structure on the right, remember, the top is like your hip, okay? The bottom down here is your ankle. What inverse kinematics allows us to do is to figure out the rotation and location of the middle point for us, okay? Let's check it out real fast. I'm going to select the hip first, the ankle second. I'm going to ignore the knee, totally ignore the knee, right? So I'm going to hold down the control key and grab that bottom guy, okay? Now, if you're in setup mode and you have that selection in tow, now we can go over into the inverse kinematics section of our toolbar, and assign IK is now ungrayed for us. Yes, sir?
I'm having trouble with separating. I tried duplicating the leg, but for some reason it won't.
Okay. How did you try duplicating it?
Same way you did. I just highlighted this and clicked duplicate, and I got this.
Yeah, good. No, they're both in the same location. Both those hierarchies are in the same location. Select the topmost item in that hierarchy, and you'll excuse me, be allowed to translate it in the scene. Great.
I'm not getting the assigned IK on grade when I select the ankle and then the hip.
Start with the hip first, then grab the ankle. Make sure you're in setup mode as well. I'm going to apologize. My allergies are going crazy right now, so if I sound like a frog on the live stream, many apologies. Okay, so with that in mind, let's do it real quick. Let's assign the IK. Now, there's a two-step sequence that we need to go through in order to dial this in and get it just absolutely perfect, okay? First, we're going to do assign IK. Now, before you touch anything, okay, go down to the bottom here where it says add goal, because this goal is really the manipulator of this entire IK leg that we're going to control. All right, and this is what does it look like. Okay, let's go over for a second and just examine the contents of our hierarchy. Yes, sir, go ahead.
Did you get assigned IK before you went to add?
Yep, absolutely. So we're going to assign the IK solver, and then we'll add the goal to the solver before we click on anything else. All right. So let's just take a look at what's been created here, because our item list is continuing to expand just a little itty bit. Okay? So under the IK hierarchy, I'm going to hold down Shift and click on the disclosure arrow. And you can see now we have an extra item in here, the full body IK solver. This is the math, if you will. This is the science behind the scene that's making this entire relationship work. Okay? In addition, we also have a goal, which is kind of like a target, if you will. This is where this is the physical item inside of our scene that we're going to be manipulating to make this part of our rig work. So let's exit setup mode for a second. I already have my goal selected in my item list, and watch what happens when I move it. Now we have kind of like a hinge. The hip doesn't move, the knee rotates, okay, and we're going to fix how it rotates here in a second. But now I can start moving this where I want it to go. Ouch. Okay. Move it back. Now the hinge should work that way. Okay. We can start creating these really cool transformations for our legs pretty easily. IK is used all over the place. Okay. Some people have pretty extensive IK solvers in their scene. Like Houdini has a really great IK system. It's pretty redonkulous. Yours broke. How did it break?
I went to go, and then after hit the Y key, and I moved it, and it moves the box, but it doesn't move.
Okay, now when you were creating the IK solver, were you in setup mode? Okay. Let's see if we can figure it out real fast. Go back in time a couple steps. Let's remove all of the IK. Keep going. Okay, that's good right there. Yeah. All right, grab the top one. Yep, that one's good. Grab one. You're in setup mode. Assign IK. Add the goal. Exit setup mode. Let's see if it works. Go ahead and grab that square. Oop. There we go. Interesting. I don't know what's going on. Okay. Try recreating the skeletal chain real fast. Maybe a new hierarchy will resolve some of those bugs. All right. So this is the power of IK. It allows us to very quickly transform our joints and get a, in finger quotes, realistic skeleton deformation, right? Allows us to get a little bit, allows us to march closer to the end result a little bit faster, right? Without as much labor into these parts of our machine, okay? It's pretty neat. You're going to see this all over the place, okay? And you know, what's cool about it is that the science behind it is transferring a whole bunch of information down this chain. So, so the location of this guy up here is going to continue to influence the chain itself, okay? And this kind of speaks to the power of IK, is that that midpoint is automatically being determined for us, not something we get with forward kinematics. So the solver is always live. It's always influencing the deformation of our rig, which is cool, which is pretty neat. So let's throw this into our basic leg over here and get to work, okay? I'm going to nuke all of this stuff, okay? I'm going to start over from scratch, and I'm just going to return my scene to, actually, let's do this. Here's an easier way of doing it. I'm a big fan of File, Revert. Revert is a great tool, because this is going to basically reopen your project file from its last saved state. So let's revert it. You're going to get a little pop over that says, are you really sure? Because we're about to erase all of the unsaved changes. Yeah, I'm sure. There it is. Okay. So let's walk through the entire rigging system. Okay. We're going to add some skeletal joints. Then we're going to bind the skeleton, right? We're going to bind it to the geometry. We're going to do our paint weights. Then we're going to add in the inverse kinematics. Okay. And then after that, we'll take a little break. and then we'll start doing the reverse footlock. Okay? The reverse footlock is basically going to allow us to raise our heel and have the ball of our foot and our toe of the foot remain on the ground at the same time, which is a critical pose for us in the animation world. We've got to have that functionality in the leg. All right, so let's do it real fast. Let's just walk through this. If you're playing along, I'm literally doing your lab assignment for you in front of you. So hint, hint, nudge, nudge. Easiest lab assignment ever, right? Let's get to work, okay? Now, I'm in an orthographic view of my 3D scene, so let's just start applying some joints here. Here's my hip. Now, I got to guess. I think the knee is kind of right around in there. And then for today, since we're going to be talking about the reverse footlock, we're actually going to add in a couple more joints. Okay, so here's the ankle right about there-ish. Okay, and then we're also going to add the ball of the foot and the toe of the foot. Now I'm going to turn off the visibility of my leg so you guys can see how this works. Okay. We talked a little bit about this last week, but it's really important that we have the ankle, the ball of the foot, and the toe of the foot. With the ankle separated out and above the heel, right? Like I said, we're going to be able to raise the heel off the ground and keep the toe of the foot where it is, okay? Or the ball of the foot where it is. Excuse me, I misspoke. So that's the skeleton that we're going to use for our lab assignment. Yes, sir?
So if we're in the data layout and we fire off the skeleton tool and we want to see where is the properties that allow us to do things like intersection and symmetry.
Yeah. Mm-hmm. So I'm going to return, yes, they have, oh, this is kind of silly. I'm not a fan of this. Tool properties, up at the top. Yeah. In the beta, it's actually down here at the bottom. Yeah, not a huge fan of that convention personally, but luckily we can pin, usually when I work at home, I usually pin my tool properties somewhere inside of my interface so that it's always accessible. All right, so, all right, yep, all this stuff looks good, pretty happy with it. Rock and roll. All right, so let's test it real fast. Let's test it. So if this is my joint, and I'm already not liking this new layout, especially for rigging stuff. Because one of the things that I love about the other setup tab is you get the global and local controls. I really like that. I always test it. Test my rig, make sure I'm actually translating across the rig correctly. Moto crashed, and I was a bad boy. I didn't move my objects where I needed them to be in the top view. Yep, that's better. Okay. All right, so let's just test the rig here for a second. Now, I'm just using the item transform tool, and this is a problem that Dominic was encountering earlier today, okay? Or when he was doing his skeleton. If you look very carefully here, I want to be able to bend the knee, right? But look at the orientation of the tool handles. The tool handles will tell us the orientation of the local pivot point very, very directly, okay? We need to make some changes in here because we need to have, at the very least, we need to have maybe the x-axis determine the natural bend in the knee, because I want to be able to go in and rotate this up along the x-axis and get the kind of the deformation that I'm after. And for me, it does it at this weird angle, which is not what I want like at all. I want my knee to be just going perfectly straight backwards, not at that weird angle. So that's a problem for me. That's a big time problem for me. So I got to fix the knee joint. Now down here on the ankle's working pretty much, oops, excuse me. The ankle's X rotation, yep, that looks good. It's ball rotation, not so hot. It goes off at a weird angle, so I got to come in here and make some big time fixes, okay? So let's make those changes pretty instantly here and see what we need to do. Now I'm going to turn on the visibility of all of my center points, okay? Let's just do it real fast. Visibility. And, okay. So if you turn on the visibility of your center points, you'll also automatically see the visibility of your pivot points as well. So right now, we're only showing the center points of whatever's selected, which is going to be cool for us, right? I'm happy with that. Now, this is the main culprit here. I need to make some changes to this. Let's go into the center point selection mode, which is 7. And let's make some changes. I'm also going to turn on my grid. Some people love working with their grid on. Some people don't. It's fine. I'm happy with whatever you want. But I'm going to make some changes to this because I want to have, let's see, I'm going to rotate the center point. Oops, hit the wrong button. And this is where having 2 views would be really helpful. Yeah, because now I can rotate it from the top and see, yep, and see how my gimbal rotates on the right. Can you guys see that? Now I can really kind of very accurately see I'm rotating, 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 and then boop, the x-axis disappears, which I know is completely perpendicular to the plane of the front viewport. Okay, happy with that, right? That's good. Shoot, I probably even can do the exact same thing. Go back into item mode for this front guy. It's good to be consistent. So I'm going to rotate, rotate, rotate. Oops, child compensation is not on, so I'm actually rotating my entire chain, which isn't what I want. Let's go back into my tool properties. Turn on child compensate so I can rotate the top joint without it messing up. There we go. Let's see. That was a bad boy. I thought I was working with my center point, but I sure wasn't. Actually, the top one's kind of right where we want them to be, so we're good for the top. Yep, good for the top, I think. Actually, no, I'm sorry. There we go. All right. Let's test this one, make sure we're good. Yep. Ankle is good. Oh, but it was the ball of the foot that was really wonky as well. That one's off at an odd angle, which is not hot. All right, so let's make some changes to that. And this is where it gets to be kind of fun, because we have to physically rotate that joint. Because I want to have the indicator for the z-axis rolling down that object. Yep. Which will put the x-axis right where I want it to be. So you kind of have to double check it. You want to have, and I'm going to grab all of these. This is kind of what you want to have, okay? And I'm just rotating the center points. If you look very carefully, here's the center point for my hip joint. See how it's the indicator line for its local orientation of the z-axis is pointed down? If we go down to the next one, here's the knee joint. Its local orientation of the z-axis is pointed down, right? So you want to have at least one axis, whether it be the x or the z, pointed down your chain, kind of pointing to each of these joints, okay? That way, you're just rotating one axis, which will give you the deformation of your skeleton, right? You're not having to rotate the x and the z simultaneously. You're just rotating the z.
When I move the rotation, the pivot point and the center point, it's not seem to be rotating it after I deselect it and select the item again. I'm still
Okay.
doing it kind of at an odd angle.
Okay. All right. There's one final step which may be the solution to your problem. Okay. And the final step in all of this is we have to freeze our transformation. Because let's take a look at this one up here. Okay. Now I have my hip joint selected. And if you look at the transform channels that are being fed into this item, we have a lot of position information and a lot of rotation information. I need to create kind of like a default pose, a resting pose for my character. So if I ever wanted to reset my character back to its rigged state, I need all of these values to be 0. 0, 0, 0 for X, Y, and Z, 0 degree rotation for X, Y, Z, and then 100% scale on all 3 of the scale channels, right? That when everything is zeroed out, your character is going to be back at the T pose, okay? Since we have transformations information plugged into this skeleton just based off of its local position inside of the scene, we need to freeze, okay, all of our transformations, excuse me. Make sure I'm in item mode here. There we go. And, hold on a sec. Why in the world they changed something without my knowing? Oh. Okay. Yeah, so this is actually good. And I misspoke a second ago. It's not freezing. This is actually a good direction. In version 11 of Modo, it said reset, freeze, and 0, right? And we don't want to actually freeze it. We want to zero out all the transformations. So it puts 0, 0, 0 on position X, Y, and Z, 0, 0, 0 on rotation X, Y, and Z, and then scale to 100%. So what we need to do, and I apologize for misspeaking, is that we need to zero out all of our transformations, which is going to keep the location of all of our items the exact same, okay? It's going to like treat the current location inside of our three-dimensional scene. That's like home, if you will. That's like where it's going to live going forward. Let me show you. I'm going to go back in time a couple steps. Now, watch what happens to the location of my leg joint here, my hip joint, when I reset. Where does it go? Back to the origin, right? So I want to have the current location inside of our three-dimensional space be kind of its origin, if you will, be its resting pose, its default pose, its original location inside of our scene. So this is where zeroing out our transformations start to come into play, okay? And we're going to want to do this for each one of our skeletal joints. And we can do them all at the same time. And I always like to do a good double check, make sure that it actually happened. Yep, there we go. So now, it doesn't matter what I do to this joint, I can rotate it like crazy. If I wanted to reset this foot back to its original state, all I have to do is go back over here into the item list, put 0 in the rotation, and now that joint's back where it was. Okay, same with this. Shoot, I can even do that if I like, right? I've really transformed my skeleton. However, just putting zeros back on all these joints will get it back to its resting pose. Okay? That may solve your problem, Dominic. It may solve your problem. Without seeing some specific, it's kind of hard. Does that help?
I'm still getting the same issue. I'm not sure if I'm edging this step, but it still feels like when I'm trying to rotate the pivot point, it's not like saving it after I drop the tool. I guess. So like I have this selected.
Turn off that. Yeah.
Okay, so I have it here, and I rotate it so it's a little more aligned.
Yep.
Then I drop it, and I grab the actual point, and it's still got
Yeah.
this and this
Go back to
doesn't-
local.
It
That's
doesn't help at all.
yeah. Well, if you look at the orientation of the center point, putting it back to local is actually setting the gimbal back to the orientation of the center point. See?
Okay,
Yeah. So we are kind of getting there. All right. Let's keep cruising. So I'm pretty pleased with this. This is looking kind of exactly how I want it to look. I've created the joints, I've zeroed out their transformations, I'm ready to bind it to the mesh itself so I can start having some big influence on my object, right? So walk me through the bind process. This is what you guys did for your homework last week. You got it. So we want to select the entire skeletal hierarchy, right? How can we easily select the entire skeleton? Double-click the root. Before I go any further, this is one step I forgot to do. I'm just going to name my joints real fast, okay? That's really, I think, a big help. So let's just call this root. And I'm going to put an root, but it's really kind of the hips. Okay. This is the knee. Ankle. Ball of the foot. And then, of course, the toe of the foot. All right. So now I can just double click on my root. It grabs all of my skeletal joints, which I like. I can hold down the control key and grab the leg, the actual geometry itself. And now I'm ready to go into my bind operation, right? I heard someone correctly say it. Let's enter into setup mode. And then in our setup tools, deformers, and there it is, bind. Now, this is going to require an experiment, right? Heat is magical. I always try heat first, but I'm not so sure heat's going to work. Yeah, look at this. It says mesh topology error. Vertices cannot be shared by non-contiguous polygons. The illegal vertices have been selected. Okay, let's check that out. Let's go into vertex selection mode. Who's the culprit? It's probably like one vert. Yeah, there's one vert in there that ain't no likey. Let's go on the inside. Oh yeah, look at that. That's funny. So this is a geometry issue. Let's see if we can fix the geometry issue before we go any further, right? So it looks like it was a vert on the inside. I'll go back in time a couple steps. I accidentally clicked off of it. All right, there's the vert. Looks like it's on the inside. Shoot, let's just do this real fast. What would happen if I just ran mesh cleanup? Would that resolve the problem? No elements to clean. Awesome. So that did not run the problem or fix the problem. Okay. So that guy in the center. Now, is that a needed vert? What happens if I just delete it? It makes a hole. Looks like there's geometry for the inside of the shoe. Okay. And the outside. This is not necessary. Let's do this. Okay. I see what they've done here. Actually, you know what we're going to do? I'm going to put that vert back in that I deleted. And I'm just going to select some geo. Yeah, now it looks like all of this stuff. Yeah, it looks like the person that modeled this this leg modeled the sole of the shoe and then the shoe separate from that. Okay, and then at some point, maybe those two verts got welded together on accident. So let's do this. I'm going to unhide the rest. I'm going to Command X. Yep, Command V. Now everything should be separate. Yep. Command X and Command V are great ways of separating pieces apart from each other. And let's try this whole thing again. Okay, let's go back into item mode. Double click my skeleton. Grab my geometry. Let's enter into setup mode. Try binding it using the heat algorithm. And it worked. I think just the visibility of my weight maps is off. Yeah, so it worked. So it's that one vert that was causing the entire problem, right? Gah! Man, whoever modeled this is horrible. It was not me, so I can say that, which is nice, right? Huh? Yeah, so selection magic here. Let's go back in time a couple steps. Hit undo. There we go. Okay. So okay, so in order to select the sole individually from the shoe itself, I just did some loop selections, right? I noticed pretty quickly that the author of this mesh actually did a pretty decent job of selecting this geometry. So I'm just going to select some loops, hold down the shift key and up arrow, and I had to, yep, I got lucky that time. Select some loops, shift up arrow a couple times, maybe one more. I'm looking through the geometry to what I can perceive as the underside of the boot. I'm going to hide it, yep, which gives me a very clear selection to the sole, right? I'm going to hold down the middle mouse button, drag out a box, which selects just the polygons that I want to manipulate. Now I can unhide the rest of the boot, and I still have the selection that I'm going for, right? I'm just trying to select the sole of the shoe. With that sole selected, I can just do Command X to cut, Command V to paste. Life is good. Now I have the boot separate from the sole. Looks like that piece is separate too. All right. Let's bind this thing again using heat. Turn on the visibility of our weight maps. And life is good. Let's test the rig outside of setup. Oops, it didn't like it. No likey'd something. Let's figure out what's going on. Did it actually bind it? Uh-oh, I'm thinking maybe it didn't. No, it tried to. I'm going to blame the power outage today for every single one of my problems. Yeah, no, it really didn't bind it. Let's figure out why it didn't bind it. Well, let's do this. Sometimes, so I just deleted my normalizing folder, so all those weight maps are no longer being used. They're still in the scene. There they all are. You're more than welcome to go in and delete those. Actually, I'm going to delete them. Let's just take it back down to, take it back down to the studs, as they say. Let's try a different bind type. Something I always experiment. Sometimes the bind types, heat doesn't work. Let's do smooth distance. See what we get. Yeah, so heat, no bueno. And I think if I remember correctly, I shouldn't be too surprised about that. I remember hearing somewhere along the line that heat doesn't work if there's a gigantic opening at the top of our mesh. And if you look at our leg, it's got a huge, huge opening there, right? So smooth distance works. Hey, look at that. Works pretty well, actually. Dun, 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 dun. Huh. I did smooth distance on this one. So it's always going to be a little bit of an experiment to see which bind type is going to give you the best result. Okay, be open to that experiment. Heat is pretty great, but clearly this is a situation where it didn't work for us, and we had to use smooth distance. Okay. All right. So with that in mind, let's just test everything out here. I'm going to look very directly now at what we have. See what kind of deformation we're getting. Yeah, so I have some work in here that I need to do. If you look very carefully, I have polygons on the underside of my mesh up here that are moving when I rotate the knees. So time to start messing with our paint weights, right? It's happening. Let's change my view to vertex map. Yep. Let's take a look at it. It's hard to see. I'm sure with the projector it's damn near impossible, but on my screen I can see a little bit of a red hue right around the border. So I need to fix that. Yeah. Okay. Exit setup mode. Now try it. Now what bind type did you use for the leg and the skeleton?
Smooth distance.
Smooth distance. Okay. And you're not getting it to work, huh?
Mine too.
All right. Well, let's see if we can figure out why it's not binding.
But it has like changed in color.
Yeah.
Adding the vertex maps, but it's not actually finding the skeleton.
Yeah. Okay. Well, let's figure out what's going on. Okay. Here's what you can do, and this is from time to time a good practice to get into, right? Like I said, just take it down to the studs, right? Go back to the raw components itself. Now, I don't have a saved version of my project file that's just the skeleton and the leg itself. So if you want to remove the influence, you can unbind your mesh by deleting the normalization folder. Bloop. Okay? Now it's no longer working. Okay? The vertex maps are still there. The weight maps are still inside the scene. You can delete those as well. Are you sure? Yeah, I'm sure. Okay. Now we're back down to basic unbound mesh. Okay. If you look at our deformers list, there's nothing over here. Okay. So we're back down to it. All right. So let's try it again. Let me just make sure that I wasn't doing something magical, or that my properties, were these the same bind properties that you guys had for the folks that didn't get it to work? Yeah. Yeah, okay, so mine's working. Yeah, Thomas.
So remove like line as segments.
Yep, bind to segments, keep that on. Yep, that's fine, just hit OK, see what you get. Exit setup mode first. Nada. Okay, do me a favor, go over to the weight maps section. Yeah, and click on knee. And in here, okay, so you're in the model tab. Go over to the setup tab. That one, yeah. Let's see if it works now. And I think it probably, no, okay, still not working here either. But at least we can see all of our weight maps.
Okay.
Interesting, okay. Let's go to our lists. Click on ankle, okay. Interesting. I'm not sure. Let's see. Evgenia, did yours start to work?
Mine started working.
Yours isn't working either?
No, I got after I went through and deleted everything.
Deleted everything, you started over?
Worked,
Yeah. Still not working. Okay. Let's see if there's an easy solution here. Exit setup mode. Okay, now grab like your knee. Rotate it.
So if it works with you watching it. No.
No, still doesn't work. Huh. Now what's different about yours? What have you done differently? And Thomas has run into the same problem. What's different about your guys's? Let's do this. Let's just take it back down to the studs. Okay, let's delete, go into your item list, and let's start deleting stuff. Let's go into the leg item. Hit the little disclosure arrow and get rid of that normalizing folder. Okay. Now down in your list section, I want you to delete all those weight maps from, yep, that one all the way down to the ball of the foot. Okay, so now we've really kind of taken it back to its raw state. Let's do the whole rig or the whole bind sequence again. Now you get the move tool or the rotate tool. Turn that tool off. Okay, now hold down the control key. Yep. Great. Setup mode. Okay. Exit setup mode now and grab just one of those joints. Doesn't matter which one. It worked there. Okay, so resetting yours helped. That helped. That is my least favorite answer to the solution, right? Just redo it. Just do it again. I really, really hate that answer. I don't know what was different in that go-around, Melissa. And I'm sure Thomas, if Thomas was here, he'd probably hear the exact same thing. Or I'd encourage him to do the exact same thing. I don't know how it's different in that sequence, but something was different. something was, the database was, not grabbing the right reference. Okay.
A lot of ones and zeros around. Like if it misses one,
It could not work.
apart,
Yeah, it could not work. So Thomas, we got Melissa's to work. Let's do the same thing for yours, okay? Let's go into your leg item itself. Click on the plus sign.
Right here.
Yep. And I want you to delete that normalizing folder. Yep. And then down here in your list, I want you to get rid of all of the weight maps from root hips all the way down to foot.
Oh,
Yep.
delete.
Yep.
Okay.
It says no items selected. Okay, that's fine.
I
Just
did just click right.
yeah, hit OK on that popover and then just right click on them instead and choose delete. There you go. All right, now let's rebind. Yep, go ahead. Let's rebind the entire thing once again. See what we get. Now double click on the root. Get out of the rotate tool. That's going to cause problems for you. Yeah.
Right here.
Yep.
Right.
Yep. And hold down the control key. No. Yeah. Hold down the control key.
Which one?
The control key on your keyboard.
Right here.
No, the control key.
Oh.
There you go. Now grab your geometry. Select your geometry. Yep, that works. Now, enter into setup mode. Let's do the bind sequence. Okay. Good. Is it okay? Exit setup mode. And just grab like the knee, just individually. There you go. And rotate it. Yeah, it worked that time. It worked that time. One of the things that you may want to consider doing is just practicing your selection sequence. Believe it or not, that's a skill when it comes to rigging, is selecting something in a very specific sequence. If you're off, even by one step, it may not work, right? For both Melissa and Thomas, this is no fault of your own. When we did the exact sequence, again, it worked. So you may have deviated from that sequence by literally one click could cause this to not work, right? Say again? Good. Good. Oh, I'm going to crash, though. I'm going to save them on my file real fast. Save as. Let's call this leg bound. There we go. All right. So let's just kind of get back together as a class. Things are looking good, but now we need to adjust all of our vertex maps, right? All of our weight maps, or paint weights, as they say. And this, this is kind of a Zen-like process, right? Where you just got to go in and start figuring out, okay, what do I want to have be controlled? Okay, when I rotate this, this is looking pretty good. I don't see any strange transformations happening downstairs. Now, I can definitely see that I have some problems in here. Yeah. Focus your eyeballs right here on the front part of my mesh. See how those verts start to move? Excuse me. It's wigging out. Here, let's do this. It's another great way to show multiple things from multiple views. Okay. Okay, so when I move this locator, see how the front part of my mesh also deforms over there on the left? So that's an indication that we need to go back in and adjust our paint weights. Okay? Now the question that we have to ask ourselves, is it this locator, is it the knee, or is it something else? It's a good question, right? Because remember, we're not just moving the knee when we do this, right? We're moving the knee, the ankle, the ball, and the toe all at the exact same time. So the culprit really could be the termination point on our chain. It could be the toe that's causing that deformation up there. It could be the toe that has the weight values mistargeted. All right, let's just check it out. Just a real quick cursory glance. Okay, sometimes working backwards is the way to go. So I'm going to I'm on my toe locator right now, and I'm just going to jump into vert mode, and under my weighting tools, I'm just going to let's just do set value at 0. Okay. I'm going to work my way up. Just weights. Boop. Okay. Just want to make sure those aren't being influenced. Cool. All right. Then we get up here. Just weights. Bet you the problem's solved now. Let's test it out, see if it works. Yeah. Mission accomplished. Let's see, any wonkiness happening here? Nope, I'm good. Yeah, there's a little bit of wonkiness happening here on the bottom of the foot. As I rotate the heel of, excuse me, the ball of the foot. There we go. Let's go back. As I rotate the ball of the foot, the heel of the foot is actually changing as well. And that's a little strange to me. You may want to fix that. It's not super offensive. Yeah, but there's a couple verts back here that I would rather not move. Let's test to make sure it's not this guy. Here, this joint here, the rotation of the termination joint should not be adjusting anything. So we'll set its weight value to 0. Cool. So now we definitely know it's the toe. The toe is not having influence on the deformation of our entire rig. Yeah, it's likely that guy. And I think what I'm going to do is that, and this is kind of the cool thing about normalization, right? Because remember, one vert can only be influenced to a percentage of 100%, right? But we can break that percentage up across a number of different items. So the toe could be influencing, you know, this back part 10%. The ball of the foot could be doing 20%. The ankle could be doing, you know, 70%. You know, it's a total kind of cumulative weight of 100%, right? We can break it up over multiple items. So if normalization is on, and it's on by default, I could go into the joint that I want to influence this thing directly. I can see over here that this section is a little lighter than the other sections, right? So instead of going through everything and saying, no, 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 I'm just going to go to this one and say, yes, I want this joint to be kind of the maximum enforcer of this part of my rig. Let's just do it real fast. So when I move my ankle, yeah, it's bending, like it's even flattening out here in the back. Okay, so let's do this real fast. Let's go into our weighting tools, and I'm just going to do a little painting in here, and we're going to paint 100%. And if normalized weights is on, okay, this is going to subtract the influence from another item, okay? And I'm just going to go in and paint the influence. Yeah, it's turning bright red now. Oops, I made a mistake. That's why the paintbrush is kind of dangerous, because you can make mistakes pretty easily. I accidentally painted off my mesh onto another part. That's how we do boo-boos. All right, that's pretty cool. Let's test it out now. Yeah, that's better. Although I really don't like how it's bending in here. See that? That's not so hot for me. See how it's just kind of curving and creating this really weird deformation? See this right here? Whoop. That's no bueno. I don't like that so much, right? So what we could do in this moment is start to smooth it out a little bit. I'm going to kind of blur the edges, see what happens. And it could be the model. Let's go up one to that guy. Yeah, it's probably more likely this feller in here. Yep, starting to relax now. Take some energy. Yeah, that's better. So there's this little dance that you play. I think what I'm going to do is I'm going to paint in, let's do this. I'm going to, yeah, sure.
Like, I don't like the way how it is ready. Can I change, for example?
Oh, yeah. Yeah, we should have done that before we bound it to the mesh. Yeah, before. Well, you'd have to go back in and remove that normalization folder, delete all the weight maps, and make adjustments to your skeleton. Yeah. Kind of in the big picture of things, sequentially, think of it like skeleton. You got to make your skeleton perfect, 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 right? Bind and paint weights. Make it perfect, 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 right? The next sequence, inverse kinematics and rigs and rig controls, okay? Those are kind of like the three major stations of a rig, okay? It gives you the most flexibility. If you're disciplined with inside of that structure, this turns into something that's a little bit easier. All right, so just real quick, what I'm doing here is just kind of artistically going in. I'm using my paint weight tool, and I've set my paint value to -10. So I'm subtracting influence into this area. And I'm just going in and seeing, maybe to resolve some of that weird cusping in the back. Yeah, I just remove the weight itself. That may have been a little too much. So now let's just go in and start to slowly build that up. So I'm painting in a value of 10% now. So if a vert already has 10% influence, now it has 20. Now it's got 30. I'm just kind of building it up. And just exploring with deformation, see how I want the mesh to respond to the vertex maps. Yeah, that's better. I'm going to turn off the visibility of my locators. They're kind of getting in the way. Yeah, that's much better. It's the back of the foot, so I shouldn't give it too much credence, but it's okay. There you go. And that now, it's a little bit more of a natural deformation kind of shape, the back of the ankle. It was really kind of hard before, but using the smoothing and then adjusting the paint weight values, I can just kind of step it back, subtract, and then add. It's pretty neat. It can be a pretty organic workflow if we allow it to be. All right, I'm pretty happy with that. Okay, let's go back to my skeleton, turn on the visibility of my locators. And now, just to get everything back to its default pose, let's reset all the positions. Yep, and now my foot's back to its original starting location. It's good.
So if I go to zero it out and I select position and it squishes itself.
We forgot to reset our transformations at one point. Yeah.
I did it once and then I reset it again and it's fine.
I don't know then. Yeah.
All right. The issue's gone, so.
Oh, there it is. Okay. And this is my big challenge. It's kind of the support mechanism for all this stuff. Without literally watching every click that you do, sometimes it's impossible for me to figure out where it's gone wrong. So please don't get your feelings hurt when I go, I don't know. Because sometimes it's impossible to know. This is not like a modeling problem where I can say, oh, your edge loop's in the wrong location. Sometimes you physically can't see the issue that's causing the problem when it comes to rigging. Yeah, question?
Did you say that he reset the rotation or the position?
Yeah, what was it? Reset the position or the rotation? Position?
Aren't you supposed to reset the rotation?
You want to reset both of them. Yeah. All three is helpful. Position, rotation, and scale. All right, so this is looking pretty good. I'm extraordinarily pleased with the result that I have here. I'm ready to rock and roll, as they say. This one can go into production. Okay, I'm a happy camper. Okay, say again?
It's squishing again.
Okay, we can take a look at it. We're about to take a break. Maybe we can figure out what's going on. One thing, this is kind of an added little benefit. Now that we have all of this rig together, and we have a really solid skeleton and some really solid vertex maps in here that's influencing the deformation of our geometry. There's another, if all you're trying to do is a simple pose, if you're not trying to animate, okay, just a simple pose, I like to draw focus to this tool because I think this is kind of a neat tool, okay? It's called the pose tool. So if you have your skeleton selected, the pose tool can be found right here. And if you look very carefully, it looks like a small skeletal hierarchy. If you turn it on, and let me just turn off the visibility of my weight maps real fast. Oops. There we go. If you turn it on, check it out. You get these wonderful little discs on the inside, which will allow you to pose your character a little bit. Now, it's pretty rudimentary. It's not super great, okay? But at the very least, you can start doing posing, okay? Like, for example, if I wanted the computer to ignore the knee joint and just give me the ability to move my ankle joint up and down, I could right-click on that control surface, the little dot, and now I can start to bend this. See how it kind of turns off the IK solver at that location? And I can start moving it around. This is great for simple posing, not great at all for animating. Like horrible for animating. But this is how a lot of traditional 2D artists and they do their posing quickly. You still got to rig it, but this allows you to go in and organically start to move all these joints around with kind of the added benefit of some inverse kinematics, because that's actually what's going on in here. It's applying inverse kinematics to the entire chain. Cool, huh? Now let's turn it off. All those little dots go away. Now the cool thing about this is all that we've done is just change the location of our position and rotation channels. So I can just reset them all and our rig's back down to its default pose again. So play around with that pose tool. It's a pretty neat tool. I like it a lot. You find that in a lot of different areas. It's kind of a little bonus tool for the day. All right, I tell you what, we've been going for about an hour and a half. Let's just take a small 5-minute break, and then we'll come back in and start looking at all the inverse kinematics and the reverse footlock stuff. Sound good? All right, let's take a break. And we'll resolve some bugs, as they say, during the break. but we have to take a cleansing breath because this is where it kind of ratchets up just a little bit, okay? So at this point in the rig, this is where I'm at. Just kind of a small little refresher, and I need to go back in time because I was noodling with things while you guys were out. Okay. So this is where we're at. It works. The hip moves, the knee moves. I'm happy with all of this. This is looking pretty stellar. Good job, Pat. You almost know what you're doing. Okay. But now we need to start adding some new functionality into the rig itself. And this kind of goes back to the idea that we were talking about earlier about kind of infusing inverse kinematics into the rig itself. Because I want to be able to grab the heel and push it up. Okay? So with this done, let's start the inverse kinematic process. And now we are absolutely on the sequence. Okay, I've written it down for you because there's a lot of steps. And if we deviate even from one, it's not going to work. Okay? So please, please, please use this. Print it out. Do whatever you need to do. But this is an excellent resource for you going forward. Okay? All right. So I have this up on my screen over here, so I'm not going to keep it up. But we are going to start to walk through it. All right. Let's do it real fast. Let's jump back over into Modo and start the sequence, okay? Like everything in Modo, the first thing that we got to do is got to select some joints. And when we're adding inverse kinematics into our scene, all we really need to do is select 2 joints with the idea that the middle joint, so in our case we have the hip and the ankle, the middle joint's the knee, it's going to be taken care of for us automatically. So let's start this process a little bit, and I need to go back in time, a couple more steps here. There we go. All right. So I'm going to grab my hip, I'm going to hold down the control key and grab the bottom. One of the things that I saw some folks doing during the break is struggling to select a joint, and here's a really great tip, okay? When you're trying to select a joint, selecting on this itty bitty circle is kind of tough, right? Right there, it's just like a 1 pixel representation of a sphere. That's tough. It's even for me, that's tough to click, to have that kind of accuracy with our cursor. Well, let's make it easy. If you click on this little rhombus shape down here, it automatically selects that joint, right? So just select the bone, if you will, below the joint, and that joint will actually be created. And in all honesty, you're actually selecting the joint. This bone is a continuation of the visualization of the influence of that joint. Also, the control key is our way of adding an item to an existing selection without having to select that middle guy, okay? I'm not doing this in the item list. I'm doing this all over here inside the OpenGL viewport. So I select the hip, and then I select the ankle, and I'm ready to rock and roll. Let's go into setup mode real fast and start applying the inverse kinematics. Assign IK like we did earlier. Bloop. And then immediately, we're going to choose add goal. Bloop. There we go. Let's exit setup mode and select the goal, which is this big green box way down here at the bottom. Okay, if it's red or a different color, not the end of the world. You're going to get a box. It's automatically going to assign a color value to that box, but it should be green or red. In addition, over in our item list, you can also see that the computer's added the item in here. We're going to rename this here in a minute, but that's the item that we have selected. So if I fire off the item transform tool, yeah, okay, it's doing it. Not well, because we're kind of breaking our kneecaps at the moment. We're going to fix that in a minute. We've successfully done it. That's how easy it is for us to go in and adjust these inverse kinematics, right? Now, the reason why we're breaking our knee joint is that the computer really doesn't have any information to tell that knee which direction to go, right? We're getting the deformation we wanted. And this is it's important to have all of our paint weights done before we go into this process so we can really understand the influence and impact of these new items in our rig to the overall part. Okay? So the location of our hip, the location of our ankle in relationship to our hip is going to determine at the moment which direction the knee bends. We're going to influence this a little bit more directly going forward in the future. So don't worry about it. We have a really great system called pole vectors that will tell the knee which direction to point, and then we'll be able to rotate just the knee by itself based on that pole vector. Point being, hang tight, we're going to fix this problem in a minute. Okay, yeah. Okay, so walk me through what you've accomplished.
Well, so far I got the whole. I'm just trying to. For some reason, I can't get the goals right.
Are you in setup mode?
No, I'm offset. Go.
Gotta be in setup mode. Right, gotta be in setup mode.
Okay. It was assign IK.
You got it. Yep. Assign IK, and then immediately hit add goal. Okay.
There's no box down here.
Okay. Let's go back in time a couple steps and see what we've accomplished. Keep going. That's good right there. Okay, now let's start selecting some joints, right?
Okay.
Which ones are you selecting? Nope. Nope. You gotta select the hip first. Hip first. Now hold down the control key and grab your ankle second. There you go. Now enter into setup mode. Now assign IK, add goal. Yep. Yeah.
It's not letting up the assign IK.
I'm sorry, can you say again?
Select the assign IK or anything.
You're not in setup mode.
Oh, I was, but.
Okay, let's drop your selection and try again. Exit setup mode for a second and just transform your object. Just rotate one of your joints. Let's just see what's going on. Okay. Interesting. Grab your ankle. Let's do it again. That one. Yep. Okay. Setup mode. Assign IK is not coming on for you. That's weird. I don't know.
Should I close it out? And
Yeah, try again. See what you get.
why are you selecting these and this angle? Like those joints too?
Yeah, because we want to be able to move the ankle up and have the knee automatically bend.
Okay, like in future, if we're gonna move the whole body, which we have to select it.
Well, we're not going to assign IK to everything. We're just going to assign the IK handles to the legs. So it's really the only place that we're going to see them.
Only for the leg.
Only for the legs. Yeah. You could do it for the arms. If you wanted to do it from the arms, which two would you select?
Probably this one.
Yep. Shoulder and the wrist. And that way, the elbow is kind of taken care of for us automatically.
Would you do IK rigs for like wings?
You could, absolutely. Yep. Yeah, and remember the whole purpose of IK is just to kind of create this piston kind of movement. So if it's a wing, yeah, that may be easier, right? If it's just going up and down, forward kinematics may give you the result. But if you wanted to have, a really cool bend in the wings, then IK could give you the solution that you're after. Mike, you had a question?
The position of the leg in space seems to be a result of cutting it and pasting it from its original mesh. Would it be a bad idea to center it, or?
This is just an example, but yeah, you could. Is yours not centered in the scene?
Oh, well, the leg itself is like off of the
Slightly below, right?
red. Well, it's not. It's more like the orientation of its turn. It seems to be natural for a character standing, but
Yeah,
it's not natural for modeling.
Right?
Should I not be moving it just because I think it's really annoying?
No, you shouldn't move it. You shouldn't move the geometry. Yep.
It's annoying.
Well, yeah. Well, that's out of your control, right? It's out of your control. You're just gonna have, as they say, you're just gonna have to live with it, okay? Because oftentimes out there in the real world, the person that makes the model is not necessarily the person that's gonna rig it, okay? So you've been supplied a model by a modeler. You're just gonna have to deal with it. You're gonna roll with it, Okay. All right. So we have now almost successfully finished this sequence in here. So we've applied the IK. We've added the goal. Now we've got to zero the position of the rotation channels for the IK goal. Now, remember, when we do this, what we're in fact doing, let's go back over into Modo, okay? What we're in fact doing is that we're saying, hey, item, your current location is now your new default location, okay? I want you to go wherever you are right here when I zero out all your transformations. If I wanted to reset my rig and get it back to its T-pose, this is where you're going to go. And that's really what we're doing when we zero these things out. And you got to be disciplined. You got to zero it out. I got my IK goal selected, so let's zero out the position, zero out the rotation. As a habit, I only zero out the objects, the channels that I know have been edited. Oftentimes, the scale is not something that it has been messed with, so I just don't. That's just me, because I'm a control freak. And now let's name this, okay? We'll just call this IK goal. Ta-da! All right. So if we look at some parts of our rig at the moment, I can grab my IK goal, and I can start to transform my rig, which is pretty cool. However, rotating it gives us a little bit of control, but I want more control. And this is where that reverse footlock part of our rig comes into play. As I mentioned earlier, the product of this is a rig where we can have our foot firmly on the ground, and then I can raise the heel, and my toe and my ball of the foot stay where they are, okay? However, at times, and if you've taken the animation class, you know this, at times we want to be able to rotate, keep that pose, right, keep that kind of weird angle, but then rotate around the toe. So this reverse footlock system gives us that functionality. And it's a little bit of setup, but it's not that bad, okay? The first thing we got to do is we have to add 4 locators into the mix, okay? Now these locators are going to have a defined role, and we need to be careful with where we place them. So let's make the locators first, plug it into the system, and get rocking and rolling. All right, so let's just do it real fast. I'm going to add a locator. Ta-da! There it is, okay? We actually need 4 of these. Now there's a number of ways that you can go in and add, you can just hit that locator button 4 times, you can duplicate it. We need 4. I'm going to call this ankle control. Okay, Control D is the keyboard shortcut to duplicate an item, by the way. Yeah?
How did you do that again? I didn't see that.
Do which part?
The ankle control.
Yeah, so I added a locator. Add a locator's up here. Right there. Okay? So we'll need 4 of these. One's called ankle control, one's called heel control. Control D will duplicate that one. This is called toe or ball control. And then last but not least, whoops, we have toe control. Okay? As one might imagine, just exclusively by the naming conventions, these are the physical locators that we're going to be selecting on our rig that's going to allow it for us to deform the mesh. Okay? Okay. So now we need to start positioning these things. Okay? Now to help you guys out, see where we're going here, I'm going to turn off the visibility of heel, ball, and toe. So all I'm seeing inside of my scene right now is my ankle control locator. Now I need that guy, this locator, to be in a laser specific spot inside the 3-dimensional scene. I need it to be in the exact same location as my IK goal or my ankle bone. Now I can guess, I could move it and get close. I could do that, right? There's a faster way of doing this inside of Modo, and I actually wish all apps had this, okay? Called drop actions. And drop actions are pretty sweet, okay? You can find them up here, okay? Now, if you click and hold on the button, you have a whole series of different options. Now, what we're going to do is that we're going to match, okay? Specifically, we're going to match position, because I want to match the position of my control locator to the position of whatever it is that I drop it on top of, okay? So it makes the rigging process a little bit more organic, okay? So match position. Now, check it out. I'm going to grab this guy, and I'm going to drag and drop it on top of my ankle joint. Bloop, and see how it just automatically goes there? We're matching the position of the locator to the thing that we drop it on top of. Okay? All right. And it's not just kind of close. I mean, it is exactly there, which is kind of nice. All right? So now what we need to do is that we need to do almost the exact same thing for the ankle and the ball. Okay, so let's turn the ankle. Oh, I did the ankle. I'm sorry.
If we're not getting it to lock into the red joint, have it on the mesh position, you just grab the locator and move it with the move tool?
No, and the whole idea is that we don't have to use the move tool with this drop action, right? Watch what I'm doing again, Dominic. So my drop action's on match position.
You literally take and you drag.
You drag and drop it. Yeah.
Just like the label of it. You just drag the name.
Well, you could. Yeah, you could do it over here in the item list.
Figured out my problem.
Yeah.
I thought it was about to crash.
That will do it. Yeah, I'm just dragging and dropping it in the OpenGL viewport. See, I'm just dragging it on top of the ankle joint. Bloop, and it's popping in. Yeah.
I'm trying to find the matchmaker.
The match position, the drop action. So I'm in the setup layout. In the setup layout, it's way up here. All right, so let's turn on the heel. Now the heel is a little bit different because, in all honesty, we want the heel locator to be kind of out here behind, just basically right behind the boot. Okay, so we're going to match position the heel to the ball locator, but then we're just going to physically transform it. Okay, we're physically going to move it so that it's kind of in the back, right in there. That's pretty good. And I like to keep it.
So we can use match position.
Yeah. There we go. And that's pretty good. Because we want to have that locator just chilling right there, kind of at the rear of the heel itself. What these locators eventually are going to turn into are locations of rotation. So I want to be able to tip the heel all the way back, kind of on its backmost, rubber sole. I also want to be able to tip the toe forward, as if we're standing up like a ballerina, okay? All right, and then we're going to do the same match position for the ball of the foot. Let's just do it real fast. And for the toe. So there goes ball, turn on toe, and drop that on the toe locator like that. And there it is. Dun, dun, dun. Aha, awesome. Yeah.
I just wanted to make sure, if I got this correctly.
Okay.
So, with ankle, so I put under match position,
Mm-hmm.
and do I just drag?
Yeah, you got it. So the ankle control locator is going to go on the ankle. The heel is going to go right back here. Okay? That's the heel. So what I did is I did match position to the ball of the foot, so it's on the same plane, the same location on the y-axis, and then I translated it back on the z and the x to get it kind of right back there at the back of the boot. And then the ball locator is going to go to the ball, and the toe is going to go on the toe. Now, much like we did before, I'm going to grab all four of my locators, and I'm going to zero out their position, because we've changed their location inside the scene. And now we're going to zero them out, so that their current location is kind of their default pose.
Go over how you got the heel in place again?
Yeah, heel is, let me just do it real fast. I'm going to go back in time a couple steps. So heel is kind of a two-step little dance, okay? Because I want the heel locator to be on the exact same plane up and down along the y-axis as the actual ball joint itself. but I don't want it on the exact same location on the X and the Z. So the Y is what I'm really looking for here. So drop action set to match position. So I'm going to initially drag and drop it on top of the ball joint, boof, like that. Then I'm going to physically move it back along the Z and the X to get the location that I'm after, somewhere right around in there. That's pretty good. Let me put these other two in here real fast. All right. And then once all of my locators have been placed where I want them, I zero out their location.
What is this called?
This is the reverse foot lock rig. And you see this in just about every rig on the face of the planet. Takes a little bit of energy to set up, but once you get it set up, it's going to serve you right.
This is part of that simple guy rig that we
It is, yeah. Simple Guy, you see this all over the place. Simple Guy is a great example of this. Yeah.
Okay, like how does it look so far?
Looks good. Generally in the right spot. And really where the target for where you want this, look where I have mine. It's just kind of in the back of the heel. I kind of keep it a little bit outside the geometry. This is where the heel is going to rotate backwards. So we don't want it like really super far away because you're not going to get a natural rotation of the heel. But we don't want it on the inside of the heel either because then it's just not, they're also going to get an unnatural rotation of the heel. All right, so let's zero out all of our locators. Zero out the position of all of our locators and get to work on the next step. Now the next step is that we have to create a small hierarchy here. Because think about it, I want to be able to move the ankle up and down, but I want the rest of these locators to also move with the ankle, right? I don't want to have to go in and start changing a crazy amount of stuff. And this is where it gets the name, reverse footlock. Because the hierarchy that we're going to create here is kind of a little strange, okay? It's a little different than one might think it is, okay? We're going to start at the ankle. We're going to first change our drop action. We don't want match position. Now we want parent in place. Because now we're going to start parenting different locators together like we did a couple weeks ago for our chain assignment and other things as well. So we're going to parent this guy, the ankle control, to the heel, or excuse me, to the ball of the foot. Simply just by dragging and dropping. Okay? We can do that one more time. With these locators, it's really thin, or the feedback that you get is very small. So I'm left clicking and dragging. Even tells you under your cursor the item that you have. Okay? And I want to drag it on top of my ball. And you know you're going to do it when you get that little rollover highlight. Yoink, there it is. Okay? If you examine the contents of your item list, there it is. The ankle has now been parented to the ball of your foot. Rock and roll, we did it. Okay? Now we're going to keep going. Yeah, go ahead.
Can we do it that way? 'Cause it's kind of difficult doing that.
Sure, you can do it however way you like. All we're doing is parenting right now. So there's half a dozen ways to get to this exact same result. I like these drop actions because it just helps me visually create the hierarchy. We're going to do the exact same thing from the ball to the toe. Whoop. And then this is where it gets the reverse because we're going to go from the toe back to the heel. So in every sense, the heel is going to be a big driver of this. There we go. So at the end of the day, this is what your hierarchy should look like. Heel, toe, ball, ankle. Yes, sir. Question?
So just like take all these and I was just wondering, like, so if the parenting tool, like, is it right here? Or
We're using the parent in place.
parent? I don't seem to have parents.
Yep.
So just highlight all of them.
No? No, there's a sequence. Let's go through the sequence again. Okay? So let's just roll through the sequence. My drop action's been set to parent in place. Okay? So I'm going to start with the ankle. I'm going to parent the ankle, left click and drag, to the ball of the foot. And then the ball of the foot gets parented to the toe, and the toe gets parented back to the heel. So if you're following along with the written directions I provided you, I'm on step 11, if that's helpful. Sometimes just seeing it in the sequence is maybe what you need.
Question.
Yeah.
Why do you do it that way?
Okay, so that's a good question. Why do we do it this way, right? Because check it out. And we're not done yet, so the functionality is not going to be necessarily seen in this moment, right? But check it out. What this allows me to do is that I can move my heel, and everything else comes along for the ride. Okay? Now, in a minute, we're going to parent the IK goal to the heel so that we grab this one locator, right? Let's grab that, boom, that one thing, we can move it up, and the entire leg is going to be lifted together. Okay? And the entire leg, when we rotate our heel, oops, I had a click disaster. And when we rotate, now I got to change the rotation of some of this stuff. Actually, before I go any further, on this particular rig, since the feet are kind of off at an angle, let's do this, because I want to fix this problem mighty fast, okay? This is not in the instructions. The instructions are made for the green guy, by the way, but we're going to deviate. We're going to do match rotation. And I'm just going to go back to that guy. I'm going to start matching the rotation of some of these joints because it's driving me crazy. Well, we're all parented together.
If we don't match the rotation, is that gonna cause problems?
It could. It could. Just do it. It's always good. I mean, it doesn't hurt.
So you just drag.
The rotation's slightly off. I'm matching the rotation channels of my joints, and it is working. I mean, they're all generally being moved down the z-axis, not fantastically, but it is working. You know what I'm going to do, just because I'm being a super nerd about all this? I'm going to do it by hand, because I don't want to mess it up. I don't want to mess up the orientation of these joints along the X and the Y. I am just going to rotate them like this. There we go. And that's probably going to do it. Yep. And once again, I'm going to zero out the rotation now. And I'll do my parenting. So back to parent in place. Ankle goes to ball. Ball goes to toe. Toe goes to heel.
We have it all parented, instead of trying to get the heel to rotate so it's more aligned with what.
You can't do it while it's all parented, right? Yeah, you got to do all that before you parent it, right? Because when you rotate the heel, now you're rotating everything underneath it in the chain. Yeah. So you want to get the position and rotation of all of your locators just dialed perfect before you start parenting them. That way you don't have, these big time problems. Okay? Let's just do a small check, make sure life is good. Whenever I finish a major sequence, I test the rig, make sure I haven't broken anything, and that it's generally, kind of doing what I want it to do. And things are good. I'm happy with this. All right. So if you think about the sequence that we're going through with the reverse footlock, there's basically 3 major stages. We create locators, we place and align the locators, right? And then we constrain the locators to existing joints, okay? Those are the 3 big sequence steps that we're going through. Create, place and align, constrain, okay? We've done step 1 and 2 of those already, so now it's time for us to go in and start constraining them, okay? I'm going to grab the ball joint, or the ball locator, excuse me, and I want to make a relationship between its joint and this locator. So really, I want the joint to be a child of the locator's position. So I'm going to select the joint first, because wherever the locator goes, I want this joint to go as well. So the locator is going to be the driver. This is going to be the parent. So joint first, locator second. This is going to get constrained to that. Let's go to our modifiers tab. Remember good old constraints, and now we're going to do a position constraint. Bloop. Yeah, that was awesome. mine did as well. Clown shoe. Now I think, let's see, what's going on mine? Yeah, I think what's happening, and it's getting some transformations. Look, it's getting some transformations somewhere up the line. Okay, so let's figure out. Maybe I forgot to zero out.
I did mine in setup.
We are likely to be need to be in setup mode. I skipped that step on my sequence. Yeah, got to be in setup mode. Got to be in setup mode for all of this, right? I apologize. Let's try it again. Joint to locator. There it is. Now, if we go out of setup mode, it doesn't explode out. Yep. So you got to stay in setup mode for the entirety of this. I apologize. I think if I remember correctly, if you look at if you're looking at the instructions, step number 1 is enter setup mode, and then you want to be in setup mode basically for the duration of this. And this is my challenge of being both the demonstrator of the sequence and the practitioner of the sequence. Is sometimes I get out of the loop. Yeah.
Position.
Yeah. So go into setup mode first, right? Now click position. Yeah. Good. Position constraint. All right. So. Okay. Now the next one is kind of strange, okay? Because we want to make sure that believe it or not, the toe, well maybe not believe it or not, we want to make sure that the toe and the ball of the foot never do this, right? Because last time I checked, our toes don't break sideways, or that's how they would do it, right? If your toes are going this way, okay, you've broken all your toes, okay? So really the big picture idea here, if we're looking at the top of our foot, okay, if this is the top of our foot, these are our toes. We do not want our toes going this way, right? Oops, yeah, our toes are broken if they're going that way, right? So if you think about it, we have a joint here, our toe joint, and then we have the ball of our foot joint. I want to constrain this guy to always point at the direction of the ball of our foot, which will avoid any sort of shearing on our toes. That would be bad, okay? Yeah, go ahead.
All right, so I positioned the ball of the foot to the ball control. But how do you get the heel and the toe?
I'm sorry, say again?
How do you do the position piece with the heel and the toe?
Yeah, we're not to the heel and the toe yet.
Oh, okay.
Yeah, we're not there yet. Yeah. So all we've done is we've done a position constraint for the ball joint and the ball locator. Okay? That way, wherever this ball locator goes, so will that joint. Okay? Now what we need to do is that we need to select the ball joint once again. Oops. Just snag it. And then I'm going to hold down the control key and grab the toe locator and apply a directional constraint. Oops. Maybe I did that backwards. Excuse me. Hold on one second, because I got to...
So it's the ball
Yeah. Oops. Let's try that.
and the,
Hold on.
but not the ball.
Hold on one second. I had it backwards. Yeah. It's you select the toe first, ball second, and then do the directional constraint. Okay? Because now the toe is always going to be pointed at the ball of the foot, which will remove the shearing. I misspoke. Okay. Locator. So now we're actually doing the joints themselves, because we don't want the joints to get out of alignment with each other. Okay? No. Just the joints themselves. Let me go back in time, do it one more time. Okay? So I grab the toe, locate the toe joint itself. Toe locator. Hold down the control key, grab the ball locator, and apply the directional constraint. That way, the toe is always going to be pointed towards the ball, and we're not going to get that shearing effect that we saw earlier. We're never going to have our toes get broken. That would hurt. Has anyone actually broken their toes before? No? Yeah.
So we do the joint, not the locator?
We're doing the joints. Yeah, we're doing the joints. Did I say locators?
You said
Did-
ball locator.
I'm sorry. Yep. This is the directional constraint is between the locators. Sorry. Well, no, actually, I'm right. Okay. We have to do the locator, not the joints. We have to do the locator because the locators are actually parented to the joints, or will be. So, I'm messing myself up here. Okay. So, let's try this again. It should help if I just follow my own instructions that I wrote down. Select ball joint and toe locator. Yeah, so we select the ball joint, toe locator. That's what I'm after. Yeah, so ball joint, toe locator. Okay? Ball joint, toe locator. I misspoke and I messed my own stuff up. I can't walk down the street and chew gum at the same time. It's difficult. That's why I wrote down the steps. And then directional constraint. There we go. Now, this happens from time to time. I wouldn't worry too much about it. See how my toe just kind of popped down? That happens. If we exit setup mode, it's not going to be too much of an influence at the moment. Probably the root cause of this bone popping down a little bit is a rotation issue with the bone itself. Okay? So it's if this turns into a problem, we should investigate this problem. Okay? The placement of the joint may be too low in relationship to the placement of the toe joint, which could also make it pop down a little bit. Okay? But like I said, if this turns into a problem, we can go back in and kind of investigate. Okay? All right. All right, so now let's go back into setup mode here real fast. Now what we need to do is that we need to start taking this goal and we need to get it into the mix a little bit here, right? Because remember, the big idea is that we grab the heel of our rig and we drag it up and the entire foot comes along for the ride. So we're going to parent this goal, okay, to the ankle locator. Ankle control way down over here. There it is. Okay? If we exit setup mode, yeah, there's a transformation happening. Let's see. Yeah, there are transformations happening along my locators. I don't know why. Did I forget to zero them out? Here, I just zeroed out the transformations of everything, okay? And I may have just forgotten to do that. Sometimes when I'm answering questions and going back and forth in time, I forget where I am. But now we parent it, and it goes even worse. That's not awesome. However, the rig works. Kinda. Let's see where we are. Hold on a sec. Yeah, okay. Let's go back into setup mode and start parenting this stuff together. Yeah, now, even worse. More than a broken toe. Yeah, this is not working like at all. It is doing what it's supposed to be doing, but let's see, on my specific one, let's see. I wonder if it's the rotation of this joint. It's rotating down. So it looks to be the ankle itself. No? That's weird. So what is pulling it up? Is it the IK goal itself? Something is physically transforming that entire crazy shape. What is going on? You know what? I'm going to take some of my own medicine. Let's just start over real fast. I don't know what's going on. Let me just walk through the sequence here real fast. Get everything up and running. Okay, there we go. Let's just add the inverse kinematics into the sequence here. It may have been because I was at a setup mode for a duration of this. Yeah, go ahead.
Did you do direction constraint or position constraint?
I've done both, right? I've done both. The first one that I did was the position constraint from the ball locator and the ball joint. And then I did a direction constraint from the toe locator to the ball joint. Okay. Hold on 1 second. I know we have questions. Just let me get caught up. See if I can resolve this bug before we go any further. Okay. And I want to be explicit to my instructions so we're all on the same page. Because I think I just missed a step. Okay. One, two, three, four. Ankle control. Ball control. Toe control. And then lastly, heel control. All right, let's get them into place. Drop action is match position. Ankle. Ankle goes on ankle. There it is. Ball goes on ball. Toe, unsurprisingly, goes on the toe. And the heel all right. Okay. Now, previously, I had set some rotations. I'm not going to do that. Now, do I would not want to do that. Let's see. I'll figure out in a second. Okay. So they're all positioned. Let's, yep. So now we got to zero out all of their locations. So now we're pretty happy with this. We've created them, we've aligned them, now we need to parent them together. Parent in place. That one goes there, that one goes there, and the toe goes back and gets parented to the heel. Go. All right. All right. Ball control gets constrained to ball, or excuse me, ball bone gets constrained to ball control. Modifiers, position. Oops, again, I'm not in setup mode. There we go. All right. That gets position constrained. Okay. Ball joint, toe locator. Ball. Direction constraint. Pops down. That's not unexpected. All right. parent, the IK goal. Now let's see if it wigs out. Ha! It doesn't wig out. Yay. Because now what we got, yep, this is what we're after. Now the rotation of these locators, I mean, they're kind of doing what we wanted to do, which is nice. Okay. Aha, excellent. It works. I'm not crazy. Yeah.
Okay, so go to what is it? Restart or
Yeah, I reverted my project file back to the previous state, and I just basically ran through steps 1 through 18 just real quickly, just to see what was going on with the transformation of that IK goal to the ankle locator itself, okay? And this is a really good kind of moment to remember, because you're going to experience this going forward, right? If something radically goes wrong, and you can't figure it out, you're going to just restart. It's faster just to rebuild it than to sit there for an hour troubleshooting why it's gone wrong. Yeah.
I need some help with the inverse kinematic, the 3D view kind of thing. For some reason, it's not working for me right now.
Okay, what's going on?
Like the root and then the ball or the ankle.
Okay, got to be in setup mode.
I know that.
Okay.
Still, it fuses too. And so
Yeah, I don't know what's going on. Hey, Melissa, did you ever fix your problem about being able to assign the IK goal?
Yeah, it was the order I did them.
The order that you did things?
Yeah, so I had to select the skeleton and then select the leg
Yep.
and then go into setup mode. And then it popped up. So I
Okay, so exit setup mode. Now select. Yep, select the next one. Now enter it setup mode. Still off. I don't know. I don't know what's going on.
because
I'm not sure why it's not allowing you to do it.
I noticed this.
No. That's completely the wrong
I know,
tool.
I know,
Yeah.
I noticed this. I know this is completely wrong. tool.
Okay. Then how does this help solve our problem if it's the completely
Because-
wrong tool?
Well, obviously, nothing's happening with this.
Yep.
It's just bugging out really.
Yeah, but this is a completely
I don't
wrong tool, right? So how does that influence the decision-making process of find the solution?
It's not.
Okay. Yeah.
Question, what's the difference between ball, ball, no, I was in 16. Select ball bone and ball joint.
Okay, so you were pointing to two different things there.
14 and 16. So
Say
if I do,
select ball bone
I
and
did-
ball
I did-
control.
Yes. Then I
Oh,
apply
it-
position. Then I select.
That's a typo. Bone and joint are the exact same thing.
Okay.
Yeah, exact same thing. That just must have been a typo. I apologize.
Is that generally like how terminology is for a lot of 3D rigging systems? Is that there's not a difference in terms of 3D rigging between a bone and a joint?
No.
Okay.
In my experience, they are the exact same thing.
Unless you like literally are modeling a bone.
A bone, yeah.
Yeah.
You got it. Yeah. At times, and in Modo, the bone is just a visualization between the joints. And when you select the bone, you're actually selecting a joint. So at times, it's just really easy to select the bone because it's big and it's something that you get a big box to click in versus selecting the joint, which could be a little bit of a challenge.
It can get real confusing if you have any kind of animation that requires you to actually like. I'm just thinking about New Doom, and it seems like it gets confusing trying to be like, oh, do I select
The bone or
bone?
yeah, and maybe the way to separate in your mind is you're selecting geometry versus selecting rigging components or objects that are included in the rig.
okay, I did the revert.
Uh-huh.
So I'm trying to, kind of jog my memory about like.
Yeah, we have a bunch that we need to go through in the next 30 minutes, so I would just recommend watching the live stream again. That way you can see this entire sequence again. Because it's going to take me 15 minutes to explain how to get you caught up, and we only have 30 minutes left in class. Okay? So watch the live stream. That's why we're doing it. All right? So let's keep going. Keep going. Okay, so I resolved my problem just by restarting because I missed a sequence step in here, and this is kind of my cross to bear, as they say, when it comes to teaching. Is very easy for me to get out of sequence when I'm helping folks. But we're all caught up. The directions are working, which makes me happy. Okay, but now, so what we've done is that we've ensured that the toes are always going to be pointing back towards back towards the ball of the foot, right? So in every sense, if you're looking at your foot from the top down, we've removed the functionality of the toes ever doing this from the top, okay? However, the other thing that we really don't have a tremendous amount of control, if you're looking at your foot from the side, is the roll of the foot. We don't want the toes to roll independently from the ball of your foot, because last time I checked, you can't do that, right? And you've broken all your bones if your toes are twisting, from the foot. We don't want that to happen, right? That would be bad, okay? Now, in order for us to resolve this, and we're going to do something similar for the knee, we're going to create something called a pole vector, which is going to define a local understanding between these joints of where to face or where to point, okay? So here's what we're going to do. We're going to create another locator. Bloop, okay? And I'm going to name this locator. And we're going to call this foot up vector. The whole purpose of this locator is to tell the top of the foot where to point, okay? Because I want that locator to always tell, wherever that locator goes, the top of the foot is also always going to point at it. This is called an up vector, okay? Now, we want this to be matched to the position of the ball joint itself. So let's just do it real fast. My drop actions and parent in place. Let's do match position. So with that in mind, I'm going to grab my new locator and match it to the position of the ball joint, okay? But I don't want this pole vector to be in the actual foot itself. I'm going to translate it locally along the y-axis so it's kind of above it, okay? Just like that. We're never going to see this in the actual final rig itself, but it does have a function. Okay. Now, the thing that's kind of fun in all of this is that we need to, remember how we did a directional constraint earlier? We need to go find that directional constraint. And luckily for us, in this version of Modo, it's right there, which is pretty cool. That makes it very, very easy. And it's just kind of parented underneath the actual scene heading itself. So here's the directional constraint between the toe control and the ball joint. Now, one of the options in here is a sign up vector. Okay? So with that directional constraint selected, I'm going to hold down the Shift key and grab that new locator. And my properties wigged out for a second. They went to the locator properties. But now I can assign that new locator as an up vector for the directional constraint. Oops, I'm not in setup mode. Let's try that again. Grab the directional constraint first, grab the locator second, and under the directional constraint properties, we want to assign the up vector. Ta-da! Okay. That's all we need to do. Okay? Yeah. All of it in setup mode, yeah. If you're not in setup mode at any one of these steps, it's going to wig out. And that's what I had happen earlier, is that I think I did a couple things outside of setup mode, and then when I exited setup mode, everything kind of blew apart. Yeah. All right. So last but not least, now we're going to parent the up vector to the toe control locator, because wherever the toe control goes, we want this guy to go in as well. So we'll parent in place. This one goes there. Now let's exit setup mode. Our rig doesn't change, which is what we're after. However, if we test it simply by going here, yep, that works. Can rotate, can rotate the heel up. Okay, I'm going to put it back down. I can grab this thing in here. Yeah, and I'm getting the functionality that I'm after. Okay, because now I can move this wherever I want it to go. and get that. Of course, my knee is breaking at the moment, so we got to fix that. But this is the target. This is what we're after. Okay. Let's go back in time. I'm going to put all these back to their default bind pose. All right. Cool, huh? Last step. Much like we did for the up vector for the top of the foot, we got to do the exact same thing for the knee. It's almost identical in sequence. So we have to create a locator, we got to position the locator, and then we're going to assign that locator as an up vector for the knee itself. Okay? But we have to have a directional constraint in here, and there's a couple things that we need to do to ensure that this works correctly. Okay? We need to create some new locators for the hip, because we want to be able to control the hip. Okay? And we also need to create some new locators for the knee itself. So the first step, we're going to create a new locator. So we're working on the hip now. Let's rename this hip control. Hip control. Let's match position to the hip joint. It's way up there at the top. Let's zero this guy out. In the directions, I want to be explicit to the directions. In the context of the much larger rig, this is actually the root leg left. That way there's no confusion going on. And let's zero out its position. All right. Next thing we got to do, create another locator for the knee control. So another one. Let's name this one knee control. This is going to be the up vector that controls which direction our knee points. Okay. Let's match position to the knee joint, which is right there. And much like we did for the top of the foot, we're just going to pull it out in front, and of course zero out its position and rotation. Okay, let's go back into setup mode. Okay, because now we're going to have to start making some relationships between these objects. Okay. Now, a lot of the problems that we're currently interfacing with when it comes to the knee is really due in part because we're getting some twist going in down the chain. Okay, our ankle has the ability to rotate any which way it wants, right? And the top of our leg has the ability just to rotate anywhere we want. We don't want two levels of rotation in there, okay? We want, the ankle should generally be moving with the hip, okay? So we're going to do a directional constraint so that all of these things are pointing the way we want. So we're going to grab the locator at the top, root leg left. This is the hip, if you will, okay? And now we're going to grab the IK goal, this guy down here. And we're going to apply a directional constraint. If you think about it, we're basically saying, hey, hip, I always want you to look at the ankle. Okay? Bloop. Okay, life is good. Now that we have a directional constraint between the hip and the ankle, this knee is going to become a little bit more important to us. Okay? Much like we did before, we got to go into the directional constraint itself. So the directional constraint is selected for the IK goal. And now we can go grab our knee. I have it already selected, but let's just do it again. So grab that one, hold down the control key, grab that guy, the knee. Okay? And there's two ways you can do it. You can go to the directional constraint properties and assign the up vector. That works. I just did that for the toe, and it worked just fine. In addition, you can also do the exact same command over here in the modifiers tab. Assign up vector. It's the exact same thing, just in two different spots. Okay? 6 to one, half a dozen to another. You get the exact same result. And you get this lovely dotted line. Okay? Okay. Make sure we zero out the knee locator. And then we're going to parent the knee locator. Let's put this back to parent in place, to the ankle control. There it is. Let's go add a setup mode. Hopefully nothing blasts apart. And there it is. Okay, let's give the old college try, as they say. Okay, don't freak out. Don't freak out, because now we have a control for the knee. That's not working at all. Awesome job, Pat. I'm the best teacher ever. Now, why didn't that work? You know, there's one other part in here that's not in play, and that's the rest of the leg itself, the rest of the hierarchy for the skeleton. Actually, let me go back in time a couple steps. I'm just triple checking my work. Yep. That's good. Yep, that's good. That's what I'm after. Yeah. I'm gonna imagine that the reason why that this isn't working the rest of the way, and that these instructions were written for the entirety of Simple Guy, okay, or for the green dude, because this, you know, this joint up here is going to be parented to the root controller, okay. Yeah, I'm not going to worry too much about that for the time being. Maybe we can smash that bug a little later on. Make sure I didn't miss anything. Yeah, no. I did it right, but without the rest of the hierarchy in there, it's, oh, I know exactly what's going on. This is my fault. Once again, I'm choosing not to follow the directions that I explicitly wrote. All right, so if you think about it, this locator here, this locator, root leg left, it's at the top, right? I didn't parent this jazz. I didn't parent the bones to the root. This is not having an influence on anything, actually. This is just a locator floating in space. It's not, it's the rotation of this thing is only influencing itself. It's not influencing the rest of the joints. And I said this in the instructions, parent existing leg bone hierarchy to root leg left, right? And quickly I interpret that as rest of the skeleton, but it's actually the bones that we have already in our hierarchy, so all of this, right? So we're going to parent that over there. Oops, I'm not in setup mode. Yeah, it gets parented to root leg left. Yeah, this now becomes, this one locator here, this now becomes the parent of the entire skeleton itself, except for the foot, okay? Knee, ankle, yep.
And that includes the full body,
Yeah, because now when we exit setup mode, it totally wonks out. Love it. Let me go back in time a couple steps. This is what happens when you go off sequence. Did I not zero something out? Root leg left. That looks good. Hips. Here, let's do this. I'm going to do my parent in place drop action. Okay. Exit setup mode. Hey, does this work? Oops. I forgot to parent this guy to the ankle. That may be why it's not working. Nope. Still wigging out. All right. It's working, but clearly when we exit setup mode, it's not. So let's do this. Okay. Let's revert and do it all over again. That way, we can really run through to make sure to see if it's working. Let's add the IK. Sign IK, add goal. Okay. Mission accomplished. Okay. Zero out the position. name this IK goal. There it is. All right. Now we got the IK set up. Let's make our 4 locators. First one, this is ankle control. Second one, ball control. Third one, toe control. And of course, heel control. Great. We've created them. Let's put them in place. Match position. I always turn the visibility of the other locators off just to make sure I'm moving the right one. That one goes there. Ball control goes to the ball of the foot. Toe control, unsurprisingly, goes to the toe of the foot. Da-da-da. Heel control initially gets set to the ball, but then we're going to transform it backwards. Somewhere right around in there. All right, great. Now, let's parent all these things in place real fast. Parent, we start at the ankle, go to the ball of the foot, ball goes to the toe, toe goes to the heel. With that all done, let's zero out the transformations on all of these guys. Life is good.
You're still recording?
Absolutely. You know what? I'm going to go back in time 1 step. Because according to my instructions, which I should know better to deviate from, we zero out before we parent. Now that they're all zeroed out, we can start the parent in place. There we go. Great. All right. Ball bone to ball control. Position constraint. Okay. Ball joint to toe locator. Ball joint to toe. Ball joint to toe locator. Direction constraint. Pops down a little bit. That's normal. Okay. I'm going to parent the left IK goal to the ankle. There it goes. All right, let's do the up vector real fast. Let's give it a good name. This will be foot up vector. There it is. Okay. Let's just do. I haven't exited setup mode at all since I started this. I'm doing 100% of this in setup mode. All right. So now let's get this match position. This goes to the ball of the foot. We'll translate it up so it's above the foot. Okay. And now we're going to select the directional constraint. And this guy, we'll assign the up vector. Awesome. It's hard to see the dotted line, but it's there. Okay, good. And then we're going to parent in place this guy to the toe control over here. Okay. All right. Now let's get the hip and the knee working. New locator. Root, leg, left. Let's match that to the top. Awesome. And zero out its position. There we go. All right, let's get the knee going in there. Yeah. Let's get specific. What step are you on?
17.
I'm not even at 17. I'm on 3, so hang tight.
Wait, you went back, right?
Like I said, I started over. Yeah. knee up vector. All right. So now we're still in match position. Let's get that going. Go. Bring that guy out. There it is. All right. All right. So the knee control, let's zero out the position here. There it is. Okay, now we get the root leg left, the IK goal, and we're going to do directional constraint. Now we go grab the directional constraint, which is already selected, by the way. It's kind of a cool thing. And we grab the knee up vector and assign it as the up vector. Okay? Yeah, and now we take the existing hierarchy. So all of this is the existing leg hierarchy, and we're going to parent that to root leg left. And I'm just going to go woo like that. Okay? Zero out the knee. I already did that. I think I have that in there twice. Parent the knee locator, parent in place. The knee locator now gets parented to ankle control, which is back over there. Now, moment of truth. Let's exit setup mode, and it still completely wigs out. Awesome. So it is not working. Now, why did it not work? That's interesting. It kind of works. We have 25% completion here. Yeah, that is peculiar. All right, let's see if I can figure this out real fast. Why is this not working? Yeah, so the homework this week is basically to get this into your green dude. Yeah. This into green dude is your homework this week. Yeah, let's just get the foot stuff in here. In addition, and this is actually pretty cool, there's one other thing that you want to do for your homework this week, and let's just talk about the goal of that, right? If we have just a simple, I want to make a simple skeletal chain here, because I don't know what's going on with this. Okay, if you have just a simple skeletal chain, we really don't want our animators going in and selecting the actual joints themselves. That's bad news bears. 9 times out of 10, that's not going to give the animators or us what we're after, right? So what we want to do is we want to add some control surfaces in here that allow us to very quickly move things around, right? To rotate things around. Okay, so one final thing, I'm going to let you guys get out of here. So I'm going to add a locator because we like locators. Let's match this. This new locator, I want to match it to the position of this thing over here. So it's in the exact same spot. Let's zero out all of its rotation. There we go. And I'm going to change its display shape a little bit. Let's make it a circle along the y-axis, along that axis. I don't want it to be solid. There we go. So now when I select it, I want it to automatically select that joint. I want it to influence it inside the chain itself. So what we need to do is that we need to insert this new control locator into our hierarchy. So I'll just call this new control. There we go. Ta-da! All right. So we need to insert it into this hierarchy. Now, I don't know where in this hierarchy it needs to go. I could guess it probably needs to go between this item here and that item there. I mean, I certainly could do it, but now this one's not parented it, and it certainly does become kind of a little bit of a hierarchical problem. We get what we want, because now when I select and translate the ring, everything below it also gets in there. But there's a faster way of doing this, okay? And that's where insert at parent and insert in place starts to work. I'm going to do insert in place, okay? Now watch what happens. I'm going to grab my little new control locator, and I'm going to drag it right there. And it did everything for me. It parented my new control to the joint that was above it in the hierarchy, but also parented the one below it to it. So it really kind of inserted it into the entire hierarchy, which is pretty rad. And this is a great way for us to very quickly go in and add a whole series of controls that allows us to influence the joints without actually selecting and working with them. Okay? So you're going to want to do that for all the joints in your skeleton, all the joints in your arms. Okay? I think for this week, what I'll do is that I'm going to remove the expectation that we do the set-driven keys for the hands, although I think a lot of you guys could probably figure that out. I want to spend some time on that because that's an important idea that that we're going to need again next week. Because next week we're going to talk about faces and morph maps specifically. So try to see if we can get that reverse footlock to work. If you're not 100% successful, don't panic. Okay? Don't panic. We will resolve these bugs, but put it in. Follow the directions with the green dude, okay? The instructions were written for a green dude, so that it should get you where you need to go, right? I'm thinking maybe what's going on here is that I don't have the exact same structure in place that we see in green dude, and that's causing it to wig out a little bit. I'll continue investigating my problems over the next week, but follow this sequence. Put the reverse footlock and all the inverse kinematics in for your green dude and see how far you get. Okay? Yeah.
So the homework is like the green guy again.
Yeah, so we're adding the inverse kinematic. Basically what we did here, we're doing it again 2 times for green dude's legs.
Just his legs, you don't want to do his arms or neck or...
If you want, go crazy. Yeah, at the very least, for the arms, for the spine and the arms and the head, you want to add those just simple locators into your hierarchy so you can control them individually. Look at this one right here. Yeah, that right there. Just a simple locator with a simple shape that allows us to very, very quickly go and select something and move it around. All right, sound good? Good luck. This stuff is challenging. Yes, sir?
When I try to directionally current joint to a locator, I'm getting that in the sequence.
You're getting a what?